All right, so this is going to be a short review of the midpoint and distance formulas. I'm going to go ahead and do midpoint first. Midpoint, like its name suggests, is just the middle point. So what you're doing is you're just going to take the average of the x values, so the x coordinates, right, x1 and x2 we'll call them. To find the average, you'll add them together and divide by how many we have. We have 2, so we divide by 2. And then you're going to find the average of the y coordinates. So you take the y1 plus y2 and divide it by 2. That is your formula, for lack of a better word. Let's go ahead and do an example. So let's say, for example, that we have the points, we'll call this A, and we'll say that this is the point -2, 4. And let's say that B is 3, 12. All right, so what we're going to do here is, first of all, identify, oh, sorry about that, identify what your coordinates are. It really does not matter which one is x1, y1, which one's x2, y2. I'm just going to call A x1, y1 and B x2, y2. But again, you could switch that. It doesn't matter at all. But following the formula, right, we're going to substitute in, and I'm just going to, our values, we're going to add them together and divide by 2, add them together and divide by 2. So let's go ahead and substitute in those values. We have our x1 is -2, our x2 is 3, our y1 is 4, and our y2 is 12. So then we're just going to take it step by step. Let me go ahead and draw a little dividing line, because otherwise I don't like how it gets confusing for me. All right, so we're just going to have here, we have -2 plus 3 is +1. 4 plus 12 is 16. The last step here is to check to see if either of these are divisible by 2. 1/2, that is as simple as that gets. I mean, you can write it as 0.5, that's totally fine. But 16 divided by 2 is 8, so you should definitely simplify that. And that is your answer right there. That is your midpoint. If you were to graph it, you'd see that it's right in the middle of those 2 points. Like if you were to graph the A and the B and draw a line connecting them, 1/2 8 will be right in the middle. Let's go ahead and also do the distance formula. The distance formula is the one that's a little more complicated. If you recall, it's actually related to the Pythagorean theorem, which was a squared plus b squared is equal to c squared. But in order to solve for c, you would take the square root of both sides, right? So you have the square root of, and then instead of the a squared and the b squared, we're talking about the side length. And you measure side length by subtracting. You might see in some textbooks where it's, or online, right, where the 2 and the 1 are reversed. It does not matter, because it doesn't matter which one's x1 and which one's x2. But the idea is that we're going to subtract the x values, square them, add that to subtracting the y values squared. So that's our formula. Let's go ahead and give it a shot with an example. So let's go ahead and use the same, oops. Let's go and use the same values if I can remember them correctly. I think this was -2, 4. And for B, I had used 3, 12. I don't remember. If not, it's perfectly fine. It really doesn't matter. Again, same idea. It doesn't matter which one you call x1 and x2 and which one you call y1, y2. It just has to be that this is a point. So if I call this x1, this one has to be y1. They're a pair, right? That's what the one, like the subscripts are for, is to say which x matches with this, which y. Well, these two match together, so they get the same number. These two match together, so they get the same number. We're going to go ahead and substitute in our values into our formula. So let's go ahead and do that. So we have the square root of I'm just going to put my little format here. All right, let's go ahead and substitute in my values. I have -2 here for x1. And then we have 3 for y1. Then we have, no, we have 3 for x2. Sorry, x1 minus x2. And then we have 4 for y1, and then 12 for y2. We're just going to go ahead and simplify this using PEMDAS, right? So first do what's inside the parentheses. So here, -2 minus 3 gives us -5. And then inside these parentheses, 4 minus 12 gives us -8. And again, follow PEMDAS. After P comes E, so we're going to do the exponents, right? -5 squared is positive 25 because a negative times a negative is a positive. So everything should end up positive in here. -8 squared is 64, right? Because again, negative times a negative is a positive. Now we're following PEMDAS. We can go ahead and add these together. That is 89. If possible, we should simplify this. Let's go ahead and see if this is simplifiable. It's odd, so it's not divisible by 2. 8 plus 9 is 17, which is not divisible by 3, so it's not divisible by 3. Not divisible by 4. Not divisible by 5, doesn't end in a 0 or 5. Not divisible by 6, because it doesn't end in a it's not divisible by 2 and 3. Is it divisible by 7? I don't think so, but let me go ahead and check. No, it's not divisible by 7. It's not divisible by 8 because 88 is divisible by 8. It's not divisible by 9 because it's not divisible by 3. This one might be prime. Is 89 prime? I don't know. I can't think of any other possibilities. So we're just going to leave it like that. If we can't simplify it, then we're done. That's the end. So again, just be careful in your labeling. Make sure that you're consistent in what you label as your, like this is x1 and y1 right there together. This is x2 and y2, they're together. And then also with the distance formula, be very careful with your negative signs. That can get tricky. If you have questions, please ask.